Not all matrices have an inverse. Here's an example of one. In fact, let's create this one together. I'm going to put this row right here. Let's just keep it simple with a 2 by 2. How about if we do a 2 and a 5? And then what I'm just going to do is I'm just going to double these, or triple them, quadruple them, whatever you like. Just double them maybe. I'll get a 4 and a 10. So the second row is just 2 times the first row. Now, if we go through our process of finding the inverse by writing A on the left, the vertical line, and I on the right, and then row reduce, we're going to get this. It's going to be 2, 5, 4, 10, 1, 0, 0, 1. Now, what we want to do here is get this element right here to be a 1. It's a 2 right now, so let's just divide the first row by 2. We're going to get fractions, but that's okay. We can deal with that. So here's what we're going to have. Row 1 is going to become row 1 divided by 2. It's going to look like this. Let's do it up here. It will be 1, 5 halves, 1 half, and 0, right? I'm just dividing every one of these numbers by 2. Second row stays the same. 4, 10, 0, 1. And now I want a 0 in this position right here. So that's a 4. I'm going to take its opposite, negative 4, and multiply it through the top row there. So here's the plan. Row 2 is going to become negative 4 times the row 1, the pivot row, plus row 2. Here's what it looks like. I'm going to multiply everything in this top row by negative 4. It'll be negative 4. Now, you can do this. Imagine the negative 4 right here. 2 will go into negative 4 twice. I'll get negative 2 times 5 is negative 10. Let's actually write that, negative 10. And if I multiply the 4 right here, 4 times a half, that's just a 2. And then finally over here, 4 times 0, that's 0. So let's circle that, and then we're going to add this to row 2. Here's an example of a 3 by 3 matrix that does not have an inverse. Let's see what happens. If we were to do this by hand, we would start by writing our form A vertical line I. So if we start with our row operations on this matrix here, if we start with our row operations here, after just a few steps, we're going to end up here. We're going to end up with this set right here. And notice, like we did in the 2 by 2, I've got that in the A side, I've got a row of zeros. So we're not going to be able to get a 1 here at all, no matter what we do with any kind of multiplication. So again, in this case, we can conclude now that A inverse does not exist. In fact, just generally, if you're working through with row operations and you get this type of a row of zeros on one side, on that left side like this, or in the last example, you can just stop and you can conclude that A inverse does not exist.